Now we will do one problem from the kinematic equations. A boy throws balls vertically upwards. He throws one ball whenever the previous one is at its greatest height. If he throws each ball after 1 second, how much height do the balls rise? This is an interesting problem. Here, what is happening is the time interval between the two successive projections. That means the boy is, for example, here we will draw the picture. The boy is throwing the balls. Okay. These are the balls he is throwing. He throws the balls whenever the ball is reaching the maximum height. Okay. So here is the another ball. Whenever the first ball reaches the maximum height, he throws the second one. Okay. Now, what is the point here is, what the point we have to grab is, the clue here is the time of ascent. That means the time taken by the ball to reach the maximum height is equal to the time interval between the successive projections. Okay, this we should know. If we know this clue, then it will be easy. Let us see, draw the line here. Okay, if we draw like this, this is the maximum height. I will write here. This is the maximum height. Whenever the ball reaches the maximum height, he throws the second ball. This is the first ball. It reached the maximum height. He is throwing the second ball. Okay. So the time difference between the successive projections is equal to the time of ascent. Time of ascent means time taken by the ball to reach the maximum height. I'll write here. Time of ascent is the time taken by the ball to reach the maximum height. Okay, and then so the time between the two successive projections, the time interval is equal to time of ascent. Between two successive projections. Is equal to time of ascent. Okay. There should not be any confusion. And here the time of ascent is given as 1 second. So he is saying that he throws each ball after 1 second means time of ascent is given as 1 second. This is equal to 1 second. That is the data given to us. Okay. Now what we have to find is how much height do the balls rise? So maximum height reached by the ball, we have to find out. So velocity, let the initial velocity is the velocity of projection. Projection is given as Vi. Just we will assume a quantity Vi. Okay, Vi meters per second. Now we know acceleration is equal to Vf minus Vi over t. Okay, therefore t is equal to Vf minus Vi over A. Okay, now what we do is we take acceleration A is equal to minus G. Okay, and then we will substitute that here so that time of ascent. TA means time of ascent. Okay. I think I wrote that here, TA. Time of ascent, TA. Okay. Time of ascent, TA is equal to VF minus VI over minus G. And then here, VF is equal to 0. VF is equal to 0 at the maximum height. Therefore, it will become 0 minus Vi over G, or this is equal to Vi over G seconds. Okay. Therefore, from this we can find out Vi is equal to G times TA, and this is equal to 9.8 times 1, that is equal to 9.8 meters per second. This is the initial velocity or velocity of projection. Now we have to find out the maximum height. Maximum height reached by the ball. Question mark. Okay, so this we can find out using the equation Vf square is equal to Vi square plus 2G. I write here maximum height as H. Okay, so H I will write. Okay, here again Vf is equal to 0 is equal to Vi square plus 2GH. Therefore, H is equal to minus Vi square by 2. Here G is minus G. I already told you G as minus G. So this is equal to Vi is 9.8. So 9.8 into 9.8 by 2 into 9.8. Okay, so this is equal to 4.9 meters. This is the answer. Okay, happy with the answer? So hope you understand the problem. Okay, in case any doubts, put in the comment section. Thank you. Bye-bye.